Jaloskis. In this video I'm going to be talking about section 3.3, properties of logs, because you can read, and I'm happy that you can read because we all understand the English language, hopefully. Even if you don't, I'm sorry. We'll talk a little bit. He's never had something in the hallway. I don't know what he's never had, though. So obviously you can see that you have your product property. Basically, that is if you have multiplication of two things inside of a log or multiple things, you can have as many things as you want. And we can split those up by taking the log of those things and adding them together. This also works for log. So if this was log, then this would be log and log. Okay, whatever it is, it works. It's exchangeable with logs and natural logs. Quotient is when you have division. Division turns into subtraction or vice versa. Power is when you have an exponent and you can take your exponent and bring it in front of your natural log or log. Remember, these can go either way. I can have this and I can get it into that form, or I can have this and I can get it to that form, get into that form. You can go any way you want. Cool, so we're going to practice some. Okay, and now that we know these properties, it's going to make solving ones like these, just like you had in 3.2, but a lot simpler. Do not forget that if you have the square root of x, that is the same thing as x to the 1/2 power, just like if you have the cube root of x, that is the same thing as x to the 1/3 power, so on and so forth. If you have the fourth root of x, that says 4, I promise that says 4. Fourth root of x, it is x to the 1/4 power, right? Fifth root of x, x to the 1/5, so on and so on. So if I rewrite this, because I want to have the same base so that I know that my properties of logs apply and I can just equal it to the exponent, well, I can change this to log base 6 of 36 to the 1/3 power. By our power rule that I just learned, or that we just learned, if we have a power, if we have an exponent, we can take it and throw it in front of our natural log by our properties. So I can take my exponent, put it in front of the log, so this is really 1/3 log base 6 of 36, which if I were to want to rewrite 36 as a base of 6 so that they will, yes, I can say log base 6 of 6 squared, so that I know that this whole thing right here is just equal to 2, so I'm just left with 1/3 times 2, which is 2/3. Yay! Alright, with this one, don't forget your bases are the same. You don't need to do a whole ton of work. So this whole part right here is equal to the exponent, which is 9, plus this whole part is equal to the exponent, which is 3. So 4 times 3, 9 plus 12, I think is 21. Ha! 21. Yay. All right, now we're still going to kind of be evaluating these if we can. But when we see the word expand, all that really means to do is I want to write this in as many logs as possible, where the only thing inside of the log is a variable, so I could have like 6 log a plus, I don't know, 12 log banana plus log blah 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 blah, but it is only one thing inside of the logs at a time. So I'm trying to get everything outside of the logs and write them all in a single log by themselves. Well, notice here, all of this is 6 times a to the 3rd times b times c to the 4th. So I know by my product rule, if I have multiplication on the inside, I can just add all of those things together while taking the log of every individual part. So 6 times a to the 3rd times b times c to the 4th, those are all going to be in their own log by themselves. Keep the same base all the way through. So this is log base 13 of 6 plus log base 13 of a cubed plus log base 13 of b plus log base 13 of c to the 4th. Once we have gotten to that point, the only thing that I have left inside of the log, well, that's a 6, so that's cool, it's all by itself. This is a cubed, but I know by my power rule I can move that out front. That's a b, it's by itself, cool. C to the 4th, I can move that out front, so I'll just rewrite this, log base 13 of 6 plus 3 log base 13 of a plus log base 13 of b plus 4 log base 13 of c. And there it would be. Because if you go through each of your logs, the only thing they have in there is a single term by itself. It's not being raised to the power of, it's not being divided, it's not being multiplied, nothing else is happening. Cool. Alright, we're going to do one more expanding one. So with this one, the first thing that I see is I have division. So I know that is our quotient property. So I can take the top, subtract it from the bottom, Morning, McKenna.
Morning.
You're in the video now. Yeah.
Oh, sorry.
Oh, I don't care. 10 years down the road, they're going to be like, who's McKenna? And then there's going to be a McKenna in the classroom, and she'll be like, he's talking about me, but that's not my voice. And now this is all in the video, so enjoy. Okay, so I can subtract these things. So ln of 3y plus 2 minus natural log of the entire bottom, so 4 cube root y. And continuing on. This, since it is addition inside there, I cannot split that up anymore. It is all together, so that log is pretty much done and touched for. This is multiplication in here. So notice you have a minus sign there. We are going to distribute that to both logs. So ln 3y plus 2, I'm not changing this one, minus ln 4 minus ln of the cube root of y. And then from here, don't forget the cube root of y is the same thing as y to the 1/3 power. So you can take that 1/3, throw it in front of your natural log, and rewrite the entire answer. So natural log 3y plus 2 minus ln 4 minus 1/3 ln y. Okay, I know this one doesn't have only one term inside of it, but there's no other way that we can split that up. It's just not possible. So it has all that we can do to it, and we are happy dappy. All right, now if we are trying to condense, we are pretty much just doing the same thing but backwards. So like in this last one, when we expanded it, if you were condensing, you would just do the same thing but backwards, like I just said. So it would start with this, and it would say condense, and then we would follow the same process. It's just I would take this 1/3 and I would put it to the power first, and I would know that's a cube root. And then since these were subtractions, they would be here, and they would be multiplying with each other, but pretty much they would be all on the bottom. So condensing, same thing, just go in the opposite direction. So I'm trying to put these all inside of one logarithm term. So with this -5 in front, I know this applies to the exponent. So there's a couple ways to doing this. I'm going to do this the one way first, and I'll show you the other way in just a second. So this is log base 2 of x plus 1 to the -5th. I'll also take this 3 and put it to the power of this one, so log base 2 of 6x to the 3rd. Don't forget, if you have a negative exponent, this is pretty much a fraction, and you can say this is 1 over x plus 1 to the 5th. So I have log base 2 of 1 over x plus 1 to the 5th power plus log base 2 of 6 cubed is 216, I think. So 216x cubed. 6 times 6, 36, 180. Yeah, that's right. Okay, and then since I have addition here, I can take the inside parts, multiply them together. So when you're multiplying fractions, multiply straight across. So there's like 216 over 1. So I have log base 2 of 216x cubed all over x plus 1 to the 5th. And there she is. Okay, and looking at the other way real quick. All right, and the other way of writing this problem out may be a little bit simpler for some of you guys, so do whatever you feel comfortable with. I notice this is -5 log squared, and if I have a negative, it's going to be division. So if I kind of just rewrite this, and I say this is 3 log base 2 of 6x minus 5 log base 2 of x plus 1. Then by my power rule, I can rewrite this as cubed and rewrite this as to the 5th power. If I have subtraction, then I know I'm going to be dividing. It is the first thing divided by the second thing, so this is log base 2 of 6x cubed over x plus 1 to the 5th. And if you don't multiply out 6x cubed, I won't be all upset or anything that you wouldn't tell me that that's 216x cubed. I don't expect you to know that on a quiz or a test if it's no calculator. But if that's easier for you, do it that way. If the first way was easier, do it that way. Whatever you guys like. All right, with this one, I notice first that I have a 4, so I can rewrite this as x to the 4th power. These are subtractions here, so that means that anything with a subtraction, everything that's being subtracted is going to go to the bottom of your fraction. And I can rewrite this as 1 log and say ln of 3x plus 5 over x to the 4th times x minus 1. If you leave it like that, I will be happy with it. Okay, and what was that, section 3.2, we saw that there were some like log of 42 that we couldn't do without a calculator, and we would have to go use a calculator. We're still going to use a calculator, but if we have a base, some calculators make it very hard to plug in a different base. So if we said something like evaluate log base 8 of 27, I don't know how to type a base 8 in a calculator. So what we can do, and what they discovered, is that if you take the log of kind of the physically higher thing and subtract it from the log of the, or sorry, divide it by the log of the lower thing, so this would be log 27 over log 8. And if you just punch that in your calculator, Shazam! There's your answer. Okay, so literally I was just punching in log, I hit the log button, and the parentheses came with it, 27 divided by log 8, parentheses came with it. Needs to look like that. Make sure you close your first set of parentheses, otherwise you will not get this answer. Yeah. Okay, take a second, try this out, pause the video, try it before you buy it. Make sure you don't, I don't know, I was trying to rhyme something but couldn't think fast enough. It's the morning, give me a break. So you can say log 4212 divided by log 78. Punch it in your calculator. Beep, boop, boop. And that is what you should get. Okay, so that is literally what I punched in my calculator. Log 4212 divided by log 78. Log 4212 divided by log 78 is 1.92. Yay! Make sure you know how to round. Yay! Do one more with you guys. Okay, and don't get freaked out by the fraction. Still just do this like you know how to. So you would have something like log 10 divided by log of 1/3. And you can punch in your calculator and get an answer. Yay! Negative 2.10. Make sure you can round. I know how to round. Don't make fun of me. I'm not. I'm just saying, make sure you know how to round. I love you guys. Y'all my booze and bass. Don't forget it. Monkey! Bum, 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 bum. Hopefully that was helpful. Have a good afternoon, evening, night. Love you guys. Bye-bye.